students. This is Vandana Bagal. Today we are going to see the topic physical and logical address and swapping. Both these topics are related to memory management. So let us start with physical and logical address. I think so you might have seen my earlier video that is related to address binding. So that video is having the basic knowledge required for this understanding of this physical and logical address. So the address which is generated by the CPU is generally termed as logical address, and the address which is seen to memory or which is loaded into memory address register is called as physical address. So this address generated by the CPU is your logical address, and at which location your program is stored, that is your physical address. Okay, so in the address binding we have seen address binding is generated at various times, at the compile time, at the load time and at the execution time. If you know where your program is going to reside in main memory, then absolute code is generated. That means your address binding is at compile time. If you don't know where your program is going to reside in main memory, then address binding is done by the relocation register. In that case, it is delayed till the load time. And execution time means when your program during the execution move from one memory segment to another memory segment, at that time execution time address binding is generated. Okay, so just now we have recalled compile time, load time and execution time address binding. So among these three address binding, compile time and load time address binding generates same physical and logical address. Compile time and load time address binding generates identical physical and logical address, whereas execution time generates different physical and logical address. Now, when your logical and physical address is different, at that time logical address is generally termed as virtual address. So, during the execution time, your virtual address and your physical address differs. It is different. So, the mapping is required. Mapping of virtual address with physical address. Mapping of logical address with physical address is needed when your logical address is not same as your physical address. And this mapping is actually done by the memory management unit. This mapping is done by the memory management unit. So how memory management unit does this mapping of logical address to physical address? With the help of relocation register. Okay, now let us understand with a simple example. As just now we have understood that CPU generates the logical address and the address which is seen to memory is the physical address. And during the execution time, your logical address and your physical address is different. Okay, since it is different, we need to map the logical address with the physical address. Okay, now let us understand with simple example. Suppose CPU has generated, assume that CPU has generated logical address. So this particular logical address, let us assume that it is 100. Okay, as just now I have told you, we need to do the mapping. For that mapping, we are using the hardware, that is memory management unit. It is having relocation register. So your logical address is get added with relocation register. So if suppose the address of this relocation register is 200. The address which is generated by the CPU is logical address. Assume that logical address is 100 and the memory management unit is having relocation register which is having the address 200. So both these addresses are get added. So 100 plus 200 is 300. That means at 300th memory location, the physical address is generated. This particular program, process or data is stored at 300th memory location, that is physical address. Understood? The conversion or the mapping of logical address to the physical address, of virtual address to the physical address. And one more important point, the set of all logical addresses of a program is called as logical address space. The set of all logical addresses of a program is called as logical address space. And the set of all physical addresses corresponding to this logical addresses is called as physical address space. Understood the concept of what is physical and logical address? What is how the mapping is performed from logical address to physical address, and what is logical address space and physical address space? Okay, now we will discuss the next basic concept related to memory management, that is swapping. As we know that the process which wants to execute, that process must be present in the main memory. So from the memory, a process is temporarily swapped out to some backing store, and from the backing store, the process which is ready to execute, that process must be swapped in to the main memory for the execution purpose. This procedure is known as swapping. So for this successful swap out and swap in, memory needs a backing store that must be a fast drum or fast disk. Now it must have two qualities, that is, as I told earlier, it must be fast and it must be large enough. It is large enough because this fast drum or disk should be able to accommodate all the memory images, and it must be fast enough so that direct access to these memory images is so fast, or this swap out and swapping procedure is so fast so that user will get the quick response, or CPU can execute number of processes within a less amount of time, and ultimately we will get the maximum CPU utilization. Now for this, system maintains a ready queue. This ready queue contains the processes which are ready to execute and which have their memory images on disk. So whenever CPU wants to execute any process, at that time dispatcher checks whether the next process in the ready queue is in the main memory or not. If it is not in the main memory, then the process in the memory is swapped out to the backing store, and the process in the ready queue is swapping to the main memory. So for this, a fast drum or disk is required. As we have already discussed, why this fast drum and disk is required? Because this drum must have two qualities, that it must be fast enough and it must be large enough. It is large enough so that it can accommodate all the memory images. It must be fast enough so that direct access is possible, and this swap in and swap out procedure is so fast so that number of processes can execute within a less amount of time. So CPU will be always busy and we can get a high degree of multi-programming. Now during this swapping and swap out procedure, as the processes are swapped out to the backing store, processes are swapping to the main memory for the execution purpose. So during this swap out and swapping, the processes are changing their addresses. So there must be care taken for this address binding. So for this address binding, if the system uses static binding, in that case the process which is swapped out from whichever memory address, it is again swapping to the same memory address. If the system uses dynamic binding, in that case, the process is swap out and swap in at any memory location easily. Okay, now this is the concept related to swapping. But here the most important point is whenever this swapping procedure is going on, that means whenever swap out of some process and swap in of the process which wants to execute in memory, whenever this task is going on, swap out and swap in, at that time CPU is idle. Okay, at that time CPU is having nothing to execute. And what is our ultimate aim or what is the ultimate performance we want with the system? That my CPU should be every time busy so that I will get high degree of multiprogramming. I want the maximum utilization of the CPU. To achieve all these things, CPU must have something to execute at every time you need. But when swap out and swap in is going on, at that time CPU is idle. So, solution for this is overlap swapping. Now, overlap swapping means when one process is executing in the main memory, at that time there is a swap-in of next process is going to be executed in the main memory. So, when one process is executing, at that time only swap in and swap out is going on. So, from this we achieve that CPU is continuously having something to execute and we will get the maximum CPU utilization. So, in this video we have covered the two important points, basic concepts related to memory management, that is physical and logical address and swapping and overlap swapping. Thank you for watching the video. Don't forget to like and subscribe my channel.